So in this lecture, we'll talk about variable mass system. Now, before understanding variable mass system, let's understand rocket propulsion. So before understanding that, let me tell you something interesting. We know that force is created by rate of change of momentum. So F is equals to dp by dt. And momentum is written as mass into velocity. If there is change in velocity of an object, it means we say that there is some change in momentum, and this change in momentum was caused by some kind of force on that object. But there is another way in which we can talk change in momentum. That is, if I write V del m. So somehow this change in mass, okay, at constant velocity can also cause change in momentum mathematically. Okay. Now, to understand this, let us study the idea of rocket propulsion. So consider here we have a rocket, okay, and here the rocket has some fuel, and I am a person on the earth and I'm seeing the rocket. So initially I see that a rocket of mass m is moving with a velocity v. So initially what do I see? Total momentum, say p1, or the initial momentum I can say is m into v. Now what happens is after some time dt, so this time is so small that I can do certain things. Okay, so in small time dt, what happens is this rocket fires this fuel outside. So if the rocket had a, so and consider the velocity with which the fuel had been fired, it's VE, exhaust fuel. Okay, so now what happens after time t? After time t, you see that this thing was inside the rocket. Okay, but now it is outside the rocket. So let this be dm mass. So what is the decrease in mass of the rocket? The decreasing mass of the rocket is minus dm, and the mass of the rocket now after time dt is m minus dm. And what happens to the velocity of the rocket? Of course, by law of conservation of momentum, velocity of the rocket will increase. Okay, so now when I consider a system, my system now contains the rocket and the fuel that has been ejected outside. Okay, so now when I talk about momentum of a system, I should be very careful. The system now is not only the rocket but the ejected fuel. Okay, now tell me what is the velocity of the ejected fuel that I see. VE is the velocity with which the fuel has been ejected from the rocket. Now truth is I see the velocity of this fuel as VE minus V. Let me give you an example. Consider you have a car, okay, and there is a person sitting inside the car, and the car is moving say at a velocity 50 meter per second. Okay, inside the car there is a driver who has a ball in his hand. What is the velocity of the ball? Since the ball is inside the car, so ball is also moving with the car at a velocity 50 meter per second. Okay, now what happens is the driver now throws the ball out of the car at a velocity 10 meter per second, let's say 100 meter per second in the forward direction. So initially the ball was in a car, and the car was moving at 50 meter per second, and now the driver throws the ball in forward direction with a velocity 100 meter per second. So 100 meter per second is the velocity with respect to the driver. So what is the velocity of the stone that I see? The velocity of the stone that I see, I am outside the car system. Okay, so I see the velocity of the stone as 50 plus 100, that is 150 meter per second. Okay, now consider the same case. There is a driver in a car who has a ball with him, and the car as well as the ball inside the car, which is also moving with the car, is moving at 50 meter per second. But this time the driver throws the ball in the backward direction at 100 meter per second. 100 meter per second is the velocity with which the driver throws the ball behind the car. So what do I see? I would see the velocity of the ball as v, which I would see is 100 minus 50 meter per second. Okay. Similarly, here also the case. Ve is the velocity with which the fuel was thrown outside the rocket, and Ve is the velocity seen by the person in the rocket, or with respect to the rocket frame. And V is the initial velocity of both the rocket and the fuel here. So of course I will make a subtraction which will tell me that this is the velocity with which the fuel is moving behind. Okay, so now if I write momentum now, so what is the momentum now? From my point of view, the system contains the rocket. What is the momentum of the rocket? The momentum of the rocket is m minus dm multiplied with v plus dv. This is the momentum of the rocket, and there is momentum of the fuel that is moving in the opposite direction than the rocket. So the net momentum, so I'll put a minus sign. Okay, and here I will write dm, which is the mass of the fuel ejected, into ve minus v. Okay, so this is the momentum after the fuel has been ejected. Okay, everything clear? So now what to do? Initial momentum is equals to final momentum. So what's the initial momentum of the system? The initial momentum of the system was mv, and what is the final momentum of the system? It is m minus dm into v plus dv, because you see, because the fuel has been ejected, the velocity of the rocket has increased. That's why v plus dv, and I put a minus sign with dm ve minus v. Okay, so what happens? You will see things getting cancelled. Okay, and you will be left with this term m delta v equals ve delta m. Let's try to understand this intuitively. So you have this rocket and you have this fuel. If you look from the center of mass of the system, then from the center of mass of the system, what is the momentum gained by the rocket? It is somewhat like m delta v. This is the extra momentum gained by the rocket. If I take dm to be very, very small, okay, because here we have cancelled a term, we have ignored a term dm dv, saying that it is very small quantity. Okay, so approximately mdv is the momentum gained by the rocket. And in the same way, for the exhaust, you see a change in mass depicts its momentum. Quite interesting, right? Anyways, it's not so accurate, but it gives an idea about it. So let's remove this. Okay, now I have to put a minus sign by hand. because delta m is decreasing. Okay, or I can say d. Let me write d. So dv and dm here. So since the mass is decreasing in the rocket, so I am bound to put a minus sign by hand. Now what? Now you need to integrate. So integrate dv from v initial to v final equals minus ve integration from initial mass to final mass dm by m. Okay, so what happens? So you find that the change in velocity vf minus vi is equal to exhaust velocity, velocity of the exhaust, ln mi divided by mf. So we also discussed some more details about the variable mass systems in problems. So when you solve problems, you'll get more idea about such kind of systems.